On Friday, we talked about inverse functions. In my memory anyways, that we just about, but not quite finished everything. Oh, if you need a copy of the notes, I've got some extras here. But the idea of an inverse function is, again, that a function does something, right? Pairs x's to y's. If we're talking about a specific function, then it does that in, kind of a specific particular way. When that function has an inverse, its inverse is going to, do exactly the opposite in a sense, right? Undo whatever that function does. I think we talked about testing for whether an inverse exists. We call that being one-to-one. A function's one-to-one when it passes a horizontal line test. So to test to see if something is a function, we use a vertical line test, which looks for whether each x value pairs with a single y. To be one-to-one, the roles of x's and y get reversed. The picture turns sideways in a sense. So we use horizontal lines. And if I see something like this, for example, that tells me that this function is not one-to-one and is not going to have an inverse, because its inverse, which again would be like the same picture but turned on its side, would not be a function. When something does pass that horizontal line test or is one-to-one or is invertible, then to find the inverse, we can either do what we did on Friday and just kind of think through like what steps happen and in what order, and then reverse those and go backwards. But sometimes that's a little bit much to ask. Or if we want to let the like algebra skills that we already have do that for us, what we can do is just swap x and y, right? So rewrite the function, but anywhere there's an x, replace with a y, and vice versa. And then solve for y. Solving for y, we're going to end up doing opposite steps, and we're going to end up going in reverse order, even if, maybe that's hard to kind of think through what that would be. So let's take a look at this example here. The first thing I want to do, if what I'm trying to do is find the inverse, is check to see if there is one. Is G 1-to-1? Well, that would mean, does G pass a horizontal line test? So I would just take a look at the graph. If somehow it's a function that you already know about, then, you can just say or sketch that or something. But this thing's just a straight line. It looks like that. It passes a vertical line test that, confirms it's a function. But more importantly, for what we're talking about right now, it also passes a horizontal line test, right? Anywhere I would draw a horizontal line is only going to hit that graph once. That's what we're looking for. So yes, that means it's one-to-one. That means it has an inverse. That means go ahead and find the inverse now, right? If the answer there was no, well, then it doesn't have one, so I don't need to go looking for it. Okay, then to find the inverse, I'm going to think of this as y equals 1 minus 2/3 x, right? We've named it g, but g of x and y are the same thing. I'm going to rewrite that with x's and y's swapped. X in place of y in place of x, wherever it shows up. This then describes the relationship between x and y that would give the inverse, right? This does it. The only thing that we still want to do then is solve for y so that we're writing it as a function, right? So solve that thing for y. What should we do first? Subtract 1, right? I want to isolate y, so I'm going to start by subtracting 1. Okay, then what? We can divide by negative 2/3. Dividing by a fraction is the same thing as multiplying by its reciprocal. So you can multiply by negative 3/2. If you want to do it in 2 steps, you could multiply by 3. Any of these is fine. I'm just writing out the longer version to make sure we kind of see where things are coming from. And then what would be left is to just divide by -2. So y, which is the inverse of g, be -3 times x minus 1 over 2. Or -3/2 times x minus 1. But the x minus 1 needs to be grouped up somehow, right? Because we need the subtraction to be the first thing that happens. And then the times 3 divided by 2 and take the opposite. Okay, so again, this does the same thing that we were kind of talking through on Friday by just saying like this happens and then this happens and then this happens. Only I don't have to be really careful and particular about like getting the order right and then reversing that order. Solving it does that for us, right? Because we end up undoing the order of operation stuff in the solving process. So this is the same idea as what we did on Friday. So don't think it's a new thing. It's just kind of automating it for us, right? Using the algebra stuff that we already done. Okay, everybody feel all right about that? All right, so that's the idea for finding an inverse. If you don't know if it has one or not, first you check, right? Horizontal line test to check. If you already know that it has one, then great. So if a problem said like, here's a one-to-one function, find its inverse, right? Then you don't need to do the checking part. But to actually find it, x in place of y, vice versa, and then solve. That's pretty much it. So there's another one there that you can try in number 2 that's going to have a little bit different feel because of the cube root. And then of course you'll get more, that's stuff for Friday. Of course you'll get more practice with the stuff in the homework, right? So sorry.
So if you multiply by like the flip thing, do you automatically put like the parentheses if that's minus 1 on top?
Yeah, so let me just do this over real quick. Kind of thinking about it that way. Again, it's not any different, but you said multiply by -3/2. Okay. So when you do that, that's going to cancel, kind of in pieces, the negative and the over 3 and the times 2, right? But when you do that, one thing to keep in mind is that you're multiplying all of this stuff that was already there, right? Like it's a single, whole piece. It's the whole right-hand side, left-hand side, whatever, of that equation. You're multiplying that by something. So when you do that, you need to group it. Yeah. So don't think of it so much as, x minus 1, but think of it as the left-hand side, like whatever's there, you're multiplying by something. That means it gets grouped. Yeah. And I think I wrote it differently, but I had it written as like 3 times x minus 1 all over 2. That's the same thing as this, right? Okay. Okay, cool, good. Anything else? Okay, great. So I think the main thing then, if we don't have like specific questions or specific things we need to look at,